The molding process is called the lost wax casting process, and it's how we make a bronze. It's the lost wax is the highest fidelity casting process on Earth. It'll capture down to fingerprint detail. It's what jewelers use, and it's what dentists use, and it's what sculptors use to create small works and also monumental scale. It all comes out. We burn it and burn it and burn it until there's nothing left in there. If the bronze came in contact with wax, it would be a real problem. And by that I mean if wax wasn't completely burned out of a mold and we poured bronze into it, the bronze would make the wax immediately turn to a gas. And a gas is a sudden expansion of volume, and the definition of an explosion is a sudden expansion of volume. So the bronze still being liquid could quite well shoot back up out of the mold because of the explosion of wax in contact with bronze. So we make really sure to burn these molds out clean and not let that happen. I've never had that happen, but the thing is I have seen imperfections based on wax bubbling into the metal before the metal solidified. We'll be pouring the bronze, we melt it to about 2,000 degrees and pour soon thereafter, and bronze literally solidifies at 1,850 degrees. So it's a small window of temperature that we're working in. So wax is one of my preferred modeling mediums. It's a coincidence that I run a foundry business with the lost wax casting process. But you were there for a burnout, I remember. It was a little out of control, but only in terms of smoke. So we got some smoke here we created. That's wax burning off. And you can see the wax falling out the bottom, dripping out all over. And literally, we got it running into pans and we collect it. But at the time, you and I were talking about the act of losting the wax, losing the wax, burning it out of the molds, and I said I reclaim it and use it for my art. So this whole piece is made out of wax reclaimed from my kilns. And when I was in art school at 20 years old, I can remember that teachers, they would hand the students materials one after the next for them to work with. And I really literally remember when I first fondled wax, and I really felt like I felt like it was oceanic in depth, and that I needed to deep dive. And that was 40 years ago, 43 years ago. And I've worked in various mediums through the years, but I love to work wax. And I kind of followed that premonition, and it worked out for me. Let me, here we go.
This is a monument to a great black woman educator from the Manassas region. She built trade schools, and this was after the Civil War and into the 1900s. Her name is Jing. And a sculptor up in the region named Christopher Hill got the commission, and I'm the sculptor enlarger and mold maker metal caster, which is an essential part to the process because sculptors make something out of clay. I make it out of clay all the time myself, and then with my foundry we make it into permanent bronze.
This is a monument that's been in the planning for years, and we're really proud to be doing it, and we're hoping it to be a very inspirational to the community of Manassas and nearby region up there.
Here we are melting the bronze ingots, and melting point is about 1800 degrees, and we bring it up to about 2000 degrees in order to pour it into the molds that we've made. And it's the lost wax casting process. So an ingot looks somewhat like an ice cube from an ice cube tray, and that's because ice is a solid below 32 degrees, and bronze is a solid below 1860 degrees. Very little has changed in the 3,000 years that bronze has been cast. We now have electric blowers rather than bellows, and we have natural gas instead of dried animal dung. Otherwise, everything else is the same. The mold is made out of earthen materials, just like in the old days, and burn out the wax. Here we have a large section of the sculpture that has been molded, and the wax has been burned out, and now we've preheated the mold till it's orange hot. And the reason for having a hot mold is so that it offers the least amount of chill resistance to the bronze as the bronze floods the chamber. So I try to bring the bronze to the lowest temperature possible so that it shrinks the most in the crucible itself, and not shrinking in the mold. So by having the mold hot, then I can pour the metal as cold as possible, cool it as thick as possible, and still have it runny. the electric hoist is very handy. I have a chain hoist from when I began my foundry business, and it's a lot of pulling of chains and noisy and gets jammed, and it's actually quite exhausting when you're dressed up. So the electric hoist makes it a bit smoother. Well, we're basically making a custom sand pit around the mold. So we're trying to get the mold down into the flask. It looks like it's getting there now. And center blocks help to fill the space. And then we pour sand in around it, inside the mold. Inside the core right here. Here's where we'll pour bronze, but the mold material is so efficient that even the hollow wax inner mold is hollow. Hard to explain. A friend of mine who was part of the casting crew for 10 years once said, the more he observes the bronze casting process, the more mysterious it gets. Well, we have put it in these buckets in preparation for filling around this. And the goal is to hold the mold stable in something that won't catch fire, but also to help stop the leak if there's a leak in the mold. So the sand is the first line of defense, and then we most likely put ingots on top of the sand to help weigh it down. So if there is a leak at the bottom or near somewhere in the mold that we can't get to, the goal is to have counter pressure to keep it from leaking out. It's a very coarse sand. So in effect it's creates an insulation because there's air between the gravel granules. So that first step was taking the mold out of the preheat kiln and into the sand pit and under the I-beam for the hoist. You can see the hoist is lined up with the pour spout for the mold. And the second whole step is taking apart the furnace to get at the crucible full of molten bronze. By the crucible, but everything else in the picture was made either by welding and fabricating or stacking the bricks. So in this case, we're just pouring one mold, and it probably took about 250 pounds of bronze to fill the mold. And the crucible can hold 450 pounds, so all eyes are on trying to successfully get this mold cast without it leaking. We're currently casting the portrait section of the Jeannie Dean monument. It's head and shoulders down to about the waist. Gives me anxiety just to watch. I'm such a quiet, peaceful guy, except when there's bronze melting, and then I'm a screamer. And but the thing is, it's very dangerous. A lot of labor goes into making that mold, but also, there are various commands I use. Forward, reverse, up, down. But if the worst thing that could happen would be if that crucible broke open, and the command at that point is jump up and don't come down. Imperfections such as sand or mold material float to the surface, and so we've skimmed off the dross on the surface, and you can see that whole big pan is full of dross. So it wasn't just pure ingot, but there was a lot of recast sections we melted down, and so chunks of mold would float up. And those are ingot molds, kind of like ice cube trays. For after the bronze is poured, we empty the crucible, get the last of the bronze out of the crucible and into the ingot mold so we can melt it again some other day. And I use a very old-fashioned way of telling the temperature, and that is when the metal behaves thick, then pour. I've tried various pyrometers, and they break in the middle of a pour, and you're left guessing. So I've just kind of trained myself to pour when the metal behaves a certain way, and therefore that approach works for any kind of metal we're casting, if it's aluminum or bronze or brass. I'm pushing it around, but also I'm watching how it sticks to that stainless steel rod, and I'm watching the color on the crucible, especially at the bottom. I'll see. Right then, the crucible dropped in, which never had happened, which means it could have dropped out. And here we're using chisels as wedges just to get through this bronze pour, and then I'll weld adjust the ring on that steel tool later so it fits better, and we've since done it in there. But it's perilously at the at the apex of the bulge on that. So there's still debris floating around, and so the third man is pushing it back. His job is to keep chunks of dross from going down into the mold. See, that's taking a lot of metal, and you don't know if it's leaking. Okay, didn't leak so far. And although the metal's still liquid in the crucible, by now the metal is solidifying in the 1/4 inch space that was left from the burning out of the 1/4 inch wax. Because the thinnest areas solidify first, and then the thicker areas, and then the thicker, and so the top of the pour spout's still liquid. But inside the mold might not even be glowing anymore. It might already be darkened. And here we've poured a couple big ingots. And the metal itself, since I'm pouring at the coldest point possible, so that it shrank the most in the crucible, it's also sticking to the walls of the crucible. So right now I'm breaking up the metal and trying to get it out of the mold so that it doesn't damage the crucible, out of the crucible, so that it doesn't damage the crucible as it continues to shrink, and it'll just tear a layer, like 1/16 of an inch of the inside of the crucible with it as it shrinks. So the mold is already cast. This is all post-cast, and it seems like drama, but the drama was really all about pouring into the mold. And it was a good-looking pour in that it was a thick flow. And the casting turned out really beautifully on this. It's a strange kind of fire, and I have many fears in life, but fire is not one of them. But again, it's not like the fire that firemen deal with. This is just radiating heat. And, the leather can start smoking and curling up, withering from being so close to the heat. So that's why we're wearing leather, is to protect, because I'd rather burn the dead cow skin than my living human skin. So it's the last line of defense. And here the bronze ingots are solidified, even though they're still red hot. And all of that is perfectly meltable once again. There's actually no waste. There's spills in the mold, in the sand pit. All that can be melted down again. It looks like, see, there's a spill stuck to the side of that mold. It's nothing. That was just on top of the surface. It wasn't a leak. And it has sand. It's got sand permeating all through it. But the thing is, when melted again, the sand floats up and becomes dross and is easily skimmed off. So the sandy chunks of strange shaped bronze are not reduced in value. They are in fact very similar to the way bronze is found when mined in the earth. And they refine it by fire, by cooking it and having the imperfections float up and skim them off. And one of the points that I make sometimes is, they talk about the earth as having a molten core of steel, of iron, and various other metals, of course, but primarily iron, and that's why we get the magnetic reading and such. But also, the Earth's surfaces move around on the molten iron, and it's called plate tectonics. So basically, that's earthy material floating on top of the metallic center, which is exactly what we're doing here, except it's ambidirectional, whereas we're just dealing with unidirectional gravity of the Earth, and the metal wants to go toward the center of the Earth, and the molten material has to get out of the way, floats on top because it's less dense. But the tectonic continental plates are earthy material floating on molten metal.
Bronze is our very archival medium. I guarantee my bronzes for 2,000 years, or 2,000 degrees, whichever comes first. Now, what I mean by that? Well, you can think about that on your own. But 2,000 years is 100 human generations. So when I'm making a bronze, I'm not just thinking about like putting it in an art show this year. I'm thinking about how it will be viewed by future generations, people who are as yet unborn, who are going to be curious about the piece and or trying to connect dots as to what it means. So I'm really trying to make art that has staying power, and in a language that isn't based on English, but based on a human story. And I never give up making art. There's 101 reasons to give up making art. Michael, perhaps you've run into a couple of them yourself. And, if I may say, sometimes they gang up on you in a gaggle of reasons to give up making art. Like 5 at once. Well, art is not for the swiftest. Art is for the most doggedly determined. It's not really for the most talented. It's for the ones that refuse to give up. Art is greater than money. It's a greater currency than money. Art ideas are a whole system of communication between artists and the audiences around the world. And the people love the arts, so we have a place, there's a reason for what we do. And there's 101 reasons to give it up. Never give up trying to make art.